Assalamualaikum warahmatullahi wabarakatuh. My name is Hakim Arif and I am from CS2403A and today and my madam is Madam Suhaila and today I will be sharing you about additional tasks in permutation question. Welcome students who are watching. I hope those who are watching benefit from this presentation and use the questions and answer as guidance for the future references. In this section, we will learn about what is permutation. So basically, a permutation is an arrangement of objects in a specific order. It shows the different ways to organize a set of items where the order matters. Permut- Permutation questions usually found in question 1 at the final exam consist of 2 or 3 sub-questions. So for the objectives, are permutation, is it important? Of course it's important. We use permutation to determine the number of possible ways to arrange or order items, which is essential in fields like mathematics, computer science, and logistics. Programming language such as R, Java, Python, and more. Permutation on our daily life. In daily life, permutation are important tasks for tasks such as scheduling, organizing event, and creating password, and analyzing probabilities in games and decision making. Why do we use permutation? They helps us to optimize and understand the variety of possible outcomes in various situations. So today I want to share with you question 1. We have 3 sub-questions and consists of 2 sub-questions in it. So Part A, find the number of integers between 3000 and 7000 which can be formed using the digits 1, 2, 3, 4, 5, 6, 7. And number 1 is each digit may be only used once and there is 2 marks. And the second is the number is even and each digit may be used more than once. Okay, for the first question, each digit may be used only once. To solve this, we need to consider the leading digit first since the number must be between 3000 and 7000. The leading digit option is 3, 4, 5, 6. For each leading digit, we select from the remaining 6 digits to form the other 3 digits. The number of permutation for each case is P and P is P parenthesis N comma R. The N is 6 and the R is 3. So 6 factorial 6 factorial is divided by 6 minus 3 parenthesis factorial. So the remaining digit is 3. So 6 factorial is divided by 3 factorial. So the answer the remaining answer is 6 times 5 and times 4, which equals to 120. Since there are 4 possible leading digits, the total number of permutation is 120 divided by 4. 120 is multiplied by 4, which equals to 480. So therefore, there are 480 possible integers between 3000 and 7000 that can be formed by using the digits from 1 to 7, which each digit can use only once. Number 2 is the number is even and each digit may be used more than once. An even number ends in 2, 4, or 6. The leading digit can be 3, 4, 5, or 6. Last digit option is 2, 4, 6, and the leading digit is 3, 4, 5, 6. For each combination of leading the last digit, the 2 middle digits can be any of the 7 digits. Number of ways to choose for the first 3 digits is allowing repetition is 4 times 7, 4 times 7, so it's 196. So since there are 3 possible last digits, the total number permutation is 196 multiplied by 3, so 588 possible ways for the number is even and each digit may be used more than once. Okay, for the question one, part B, a company has 25 members that consist of 7 engineers. In how many ways a committee of 8 members be selected if first, more than 5 engineers are included. Second is at most 2 engineers are included. So for question 2, part B, a company has 25 members that consists of 7 engineers. In how many ways a committee of 8 members can be selected if number 1, more than 5 engineers are included. To find the number of ways to form a committee of 8 members with more than 5 engineers, we need to consider two scenarios having 6 engineers and 7 all engineers. For case 1, 6 engineers and non-engineers and 2 non-engineers. For the first is selecting 6 engineers to from 7. The number of ways to choose 6 engineers from 7 is given by binomial coefficient, binomial 7 and 6, which equals to 7. And then they represent the number of ways to select 6 engineers from a pool of 7. Then second is selecting 2 non-engineers from 18. Remaining members is the number of ways to choose 2 non-engineers from 18 is given by the binomial coefficient, which is 18 to factorial 18 divided by 2, so we will get 153. 7 times 153, we get 1071 ways. And then for case 2 is 7 engineers and 1 non-engineer. So selecting all 7 engineers, the number of ways to choose all 7 engineers from 7 is binomial 7 out of 7, so we equals to 1. And then the total number case of selecting one engineer from 18 is 18 out of 1, so we'll get 8 binomial 18 1, so get 18. So 1 times 18 is 18. So the total number of ways is 1071 plus 18, so 1089 ways. For the question 2 is at most 2 engineers are included. To find the number of ways to form commit of 8 members with 2 most engineers, we need to consider 3 scenarios having 0 engineers, 1 engineer and 2 engineer. For the case 1 is 0 engineer and 8 non-engineers. 8 non-engineers from 18. The number of ways to choose 8 non-engineers from 18 is binomial 18 8, so 43,758. For the case 2 is 1 engineer and 7 others, 7 binomial 7 1, so equals to 7, and 18 binomial 18 7, so we'll get 31,824. So divided by 7 is 222 7,768. For the case 3 is 2 engineers and 6 others, binomial 7 equals 2, we will get 21, and then 18, and then we select 6 non-engineers from 18, so 18 total of engineers, and then 6 non-engineers, we will get binomial 18 6, we will get 18,564 divided by 21, so we will get 389,844. So the total ways is plus case 1, case 2, and case 3, we will get 656,370 ways that we can at most 2 engineers are included. So for the part C is 5 marks. So question 1 part C, find the number of arrangements of the letters in the word mathematic if there are no restrictions and the two A's are adjacent. Adjacent means they are together. The two A's are together. Okay, so for the part C, mathematic, the first is no restriction. The total letters is 10 with repeated letter A, T, M. For the formula for arrangement is 10 factorial divided by 2 factorial times with 2 factorial times with 2 factorial. So 300, so 3,000,000 628,800 divided by 8, so we will get 400,053. We will get 453,600 ways, which there are no restrictions. For the second is the adjacent letters is A and A. Treat the two A's in a single unit. We now have 9 units for arrangement: M, T, H, E, M, T, I, C, and A adjacent. So for the formula for arrangement, we've combined AA is 9 factorial divided by 2, 2 factorial times 2 factorial, 2 factorial. So we will get 362,880 divided by 4, and then there is 90,720 ways. For mathematics, for adjacent letters, A, A adjacent. So we have ended our session. Thank you for listening and watching. I want to thank Madam Suhaila for giving me this opportunity and chance to correct my mistakes. And I hope to see her in the future. I hope to see her in the future to teach me other subjects. So thank you for listening.